Our second speaker of the morning session is Tadashi Takayanagi from KAIST, who needs no introduction. And he's going to tell us about CFT dual of dS3 and pseudo entropy.
I'd like some organizers for this very wonderful occasion, and also I'm very honored to have this opportunity to give a presentation in the Oguri-san's 60th birthday. Congratulations. So before I start my research talk, I would talk about a little bit relation. So when I was a graduate student, at the same place as Oguri-san in Tokyo University. And that time, I really learned quite a lot about string theory, especially about the worldsheet formulation from various Oguri-san seminar papers, these great ones. Especially one of my favorite paper that time was this one. Actually, it's related to this difference in Calabrian spaces and their means, written by Oguri, Ozanri, which I learned quite a lot about boundary state moments. That is actually one of my, very important project direction for all of my right? Also, I quite a lot of SL2R, restricted model, and possess SL2R U1 from this paper to dimension from all singularity. My problem in today's talk is it kind of related using similar techniques related to SL2R and also SU2 algebras. And so finally, also, of course, this is dS3, CFT2, basic literature is this one, the center of papers, which we can solve dS3 string theory. And so after that, I joined in Harvard University as a postdoc fellow, where Kamran and was there. And there I was quite fascinated by this famous paper of this Oguri. So really, OSB conjecture is a very beautiful relation between graph code partial function and topology string function. And fortunately, this time, because I was in US, I have several occasions to talk to some physics. And one of them is like this, we are in the same symposium. After this is in Egypt. Yeah. This is great. Yes. So we share the same taxi line from Cairo Airport to Alexandria. This is the photo. Time and then 9 It's very great memories.
I see.
And then, so after that, sometime later, so I joined company. I came here, faculty member, and I really thanks to Oguri-san, also Jaewon-san for kindly inviting me to join this great institute, and really enjoy this research environment here. And now I'm in Kyoto University. This is a Yukawa Institute for theoretical physics, and I have very rare opportunity to collaborate with Oguri-san quite recently about this Boltzmann conjecture in AES, and so we use end-load worldline dynamics to justify coordinate conjecture, and I really thanks to Oguri-san for kindly inviting me to also this new exciting subject. And so much really quite recently, this April, so Oguri-san kindly visited Kyoto University, and Oguri-san gave a very beautiful colloquium in physics department. And after that, he gave a really wonderful lecture about symmetry, quantum theory, and gravity in our institute. It's a lot of people coming, and I'm sure that a lot of young people very stimulated. Okay, so let me yeah, I'd like to now do this research talk. And so here I wrote like some basic facts of this quantum gravity in various spaces. And of course, we know from space quantum gravity, we can solve basically by using worldsheet technique in string theory, this sample. And in anti-Logita space, we can use dS3. So dS3 relates, of course, gravity in anti-Logita space, including quantum gravity to non-gravitational theory, conformal theory. So it might be possible to understand quantum gravity by using dS3. There's lots of And then what about Logita space? And in Logita space is of course very difficult. It's very famous that it's very difficult problem. But of course, this is very important to understand our elements. And But again, I think there are many ideas, but my hope is to use again this holographic approach to understand this digital space quantum gravity. So in my talk, I'd like to develop dS3 duality in this context, and also the basic very the question is how we have some emergent type of Euclidean CFTs, how we can understand this. I'd like to just propose some honest situation. And so here is just a well-known sketch of the CFT. So this first proposed by Somiya, later developed by YITP. So this is basically, I think it's very close to the formulation by Madasena. And we start with a Houghton-Fokin wave function we have in mind. So we start with some Euclidean region, Euclidean path integral, which can instant or tunneling effect to create universe. And later we have real time evolution. And at a later time, t goes to infinity. At the infinite future, we have a space-like boundary is there. And so if we just use standard idea of holography, it's bulk is dual to boundary. So we reach this idea that bulk digital space is dual to some theory lives on just this space-like boundary. And because of the symmetry reason, so we expect that this space-like theory looks like conformal theory, Euclidean d-dimensional conformal theory. And if this holography works in usual way, then bulk Lorentzian space, d plus 1 division Lorentzian space is dual to d-dimensional Euclidean space. And so I'm basically following this formalism today. And so digital space is like this. And I'm using this metrics, and NDS means digital rings. And the basic relation between this, like bulk to boundary relation, is this one. The basic relation is that we are doing we're fractional of digital gravity. Basically, it's a kind of partition function, which path integral over this trajectory in gravity. So it's equal to a Euclidean partition function. And so, but we have to note a very important that so we have some Euclidean CFT appears, but of course Euclidean CFT appears as a phrase, just not Euclidean version of ADS CFT. So ADS CFT, so Euclidean version of ADS hyperbolic space is dual to some Euclidean conformal field theory. This is just standard ADS CFT. But here we again encounter some Euclidean CFT, so it should be different. And because we are talking about the emergent time and so on, so it should be very exotic. And so this is, of course, we have to be careful. And my talk, I'm going to talk about everything very exotic, I should say. And so that sense, we need to be very careful about interpretation. And I just give one possible interpretation. And so, but for example, if we look at some literature, there are only very few examples, no. And so, for example, one basic one is that this 4-dimensional higher spin digital gravity is argued to be dual to 3-dimensional SPM theory, SPM vector model. But this is as opposed to when vector model, this vector it looks like scalar and spin 0, but it's actually anti-commuting. So it's like ghost. So already it's non-unitary. Theory is different PX. So all this exotic basically means it's very non-unitary. And also if we compute this entanglement entropy, assuming holographic calculation, this is also in the final part of my talk. I'm also talking about this. But anyway, we get some complex valued quantity, and it's completely different from usual. The main reason is that there are no space-like extremal surface which connects 2 points on the boundary. And but also at the same time, example of some duality, CFT dual, which is dual to Einstein gravity, Einstein digital gravity is still missing. So we give one such a possibility in 3-dimensional case. And maybe I should mention there are also recently the other possibilities to talk about holography in digital space, like dS duality, PT bar, and static particle holography by such kind of service we have been previously. But I'm not going to talk about this. I'm just focusing on more traditional version of dS CFT. And so here are useful facts of ADS CFT. This is very, very, very well known. So this symmetry agreement, of course, SO2, D, killing symmetry, geometrical symmetry of ADS is equivalent to conformal symmetry of Lorentzian CFT. And about degree of freedom, so divergence. So we have the UV divergence in quantum field theory. So we usually relate this divergence to UV cutoff of the UV divergence of conformal field is related to just geometrical cutoff of anti-Rochester space where we have large volume gets divergent. And if we pick up some finite piece, we encounter this ratio. Normally we get this ratio. So ADS radius to some power, A radius is ADS radius to some d-1 divided by g Newton. This is the dimensionless quantity, and this is basically central charge. So I'm going to also use this for DS case. And so now we would like to move to dS3 from ADS3. So let us assume we assume just a Logita Einstein gravity, and what kind of result we expect. So D plus 1 dimensional Logita space looks like this metric, and so we can do some weak rotation to Euclidean Logita, just semisphere, just sphere. This LDS is a DS radius, and then this is as usual we do some kind of analytical continuation to ADS radius. So LADS is ADS radius. It's take up the imaginary variable if we think about logical space. And that's one also. And then we get this hyperbolic space, Euclidean ADS. And so for that argument, so previously we see that central charge is LB ADS over GA. But this is in terms of DS language, we have I here, I to some power. So this is actually cosine of modularity, and but dimension is also dimension sensitive and d minus 1. So if we think about even dimensional conformal series, somehow central charge becomes imaginary. So what we run here is a central charge is dual CFT of this Logita space. It looks like imaginary for even dimension, and we are focusing on d equal to. So this is true. The other important fact is that, so we are normally take a large, the simplest limit is of course large radius limit. So then central charge in that limit obviously gets divergent. And this part is get divergent. This is the two basic force. So I just explained some sketch of dS3 and then we'll give some construction of this dS3 CFT2 and confirm our proposal by calculating free energy, and we'll talk about some relation to higher speed holography, and finally talk about entanglement, some generalization for what we call Pseudo Entropy interpretation and how we get some emergence. So let's get some insight of how we can construct DS2, DS3, CFT2. So we combine two very well-known facts. Most of this audience is familiar with this, I think more than I, so I will hesitate to talk the details, or let me go just briefly. So first fact is the both actually given by this famous paper. And so this is actually first one is this relation between Chern-Simons gauge theory and 3D gravity. So this is a basic statement that somehow this so this standard Chern-Simons theory, and we have some two connection A and A bar, the SU both SU2 gauge group, and the claim is that this theory describes Chern-Simons. This theory describes Logita space, and so we have a two gauge group and SU2, and each has a Chern-Simons action with some minus, but we put some I. It is a usual notation. So, but this I, if we put I, so this is not, we cannot relate this to Euclidean gravity, so we need to remove this I. So we take this level, Chern-Simons to be imaginary. And its coefficient is actually turned out to be Logita radius divided by 1. So this should be very large for say Logita. And here the connection A is type I and the connection as usual. This is one basic fact. And another basic fact is the relation between SU2 Chern-Simons theory and SU2. So SU2 Chern-Simons gauge theory and SU2 SU.
So when you consider this Chern-Simons theory, SU2 Chern-Simons, SU2 cross SU2 Chern-Simons theory with imaginary K, so is the action bounded from below?
I don't know, because also the action is not bounded.
Right.
It's not.
So you don't worry about it because because since it's a difference of the two Chern-Simons action,
Yeah.
so clearly, I mean, it's not cannot be bounded.
Yeah, I think so. Well, actually, I'm not right.
So more worry is gauge invariance.
Anyway.
Is gauge invariance destroyed? Because usually the large gauge transform should be used.
Yes,
right.
We omit large gauge transform. That means no perturbative summation is not that solid.
What does that mean? You're allowed to do that?
Yeah, so anyway, so I'm just satisfied with the fact that this theory is equivalent to Einstein gravity. So we can rely on these guys and just equate action. So I'm not talking about no perturbative completion. I think maybe there are arguments, but
I don't think there is a universal covering of SU2 group manifold that is simply connected. So you would worry about whether there is a non-trivial pi 3 or something.
yes. Sorry, I'm worrying about non-perturbative.
Okay.
Yeah, so just stay with.
I see.
Yeah, because I'm focusing on only one fixed background and just very small perturbation based traits. So yeah, I think that's very important. But maybe also there are many results of the maybe no. Sorry, no, not something. Thank you very much. Another fact is this SU2, so this SUN Chern-Simons theory dual this SUN yeah. Understood that.
So just mention your K is imaginary.
Yes,
So your central charge is not imaginary, it's just a fake.
And yes, that's such a very. So the central charge is very important. So this is a so we can calculate Chern-Simons, we can relate this Chern-Simons function in terms of S matrix, just modular S matrix in let's do in a model. So we have this very beautiful formula of this sign.
Do you still insist the J to be like half integer?
Actually, that's regular. In there, I just continue to continuous value.
I see.
Yeah. So we actually extended this. We are not focusing on rational SU2 theory.
Why do you insist on thinking of this as SU2? Shouldn't I more like thinking about this like SL2C?
I think yeah.
It may make more sense to think of.
Yeah. So use this form.
So just for the purpose of notation.
Yes, and in the end also it's like you have to use Liouville theory rather than SU2 theory because the Liouville theory is included as in SU1.
Yeah, something related. If you go to analytic continue, there's a continuous representation.
Yes,
This is a use.
So yeah, of course we then go to K is not integer, so it's go beyond. We have some evidence that also this formula it's one scale, right?
So you think that with this proper generalization, like modular transformation rule still holds?
Yeah, but we can confirm it by other theory like Liouville theory. So Liouville theory also have a modular S matrix and also get the same result. So
I see.
we think probably.
Yeah, because often when you have this continuous transformation, there is like mock property of the partition function where you do the modular transformation of conformal block and there are some kind of some junk.
Yes. Yeah,
so yeah. You don't assume this.
Yeah, we don't touch.
Okay.
Thank you very much. But they are related to the central charge, so we have some parts of that. So if we just combine numerically, dS3 Dojita gravity is equivalent to SU2 Chern-Simons gauge theory and equivalent to SU2 SU2. Maybe this is just dS3 because anyway we get to this CFT, but it's not really highly non-trivial. So because if we assume this, then we have this at first we have the Einstein gravity limit as we see this K goes to infinity. We have I, but it goes to infinity because dS radius should be divergent. But if we do so SU2 central charge is 3K over K plus 2, so if we take we get 3. So but we expect central charge should be also very large to have a macroscopic body time. So this is the first part of but actually in the end we actually find that the right limit is given by this way. So K goes to -2 plus some small imaginary piece. And the small imaginary piece is a G Newton divided by dS radius. And if we assume this, then central charge counting agrees what we expect from the CFT, and we check this idea. So comparing this, also, if we some small excitation, so this are all related to this obvious excitation. So J is now taken to be continuous value. So having this continuous excitation, probably going also standard integral excitation, and then this delta J is related to the energy. It's I LDS. And also standard dictionary in DS.
So is it related to what people like Gabadier and Gopakun
Yeah.
are going to mention this?
Yes, yeah,
Okay.
that's yeah.
Because they are also considering similar limit in somewhat different context.
Yeah. Different, but okay, their duality is actually resolve some this part.
I see.
Yes. And, yeah, so for this, so here we keep in mind more, maybe more properly, we have in mind CFT or view like CFT because we are taking more rational case. And but anyway, so the claim is like just here. So claim is here. So this k minus 2 limit of SU2 is in the model, and we get a central charge goes to infinity, and this is dual to Einstein gravity. This is point of Einstein gravity, not the. So you can generate SUN, then we get the higher spin. Here we have a very Einstein, and it's radius is positive 18. And this is just a conjecture, so we have to check this calculating something, and we calculate free energy. And so this is just a normal Einstein-Hilbert action in digital space, and there are no boundaries, so we don't need to put boundary down. And we compare function. So first of all, so we can think about some CFT side. So we have S matrix, and but we have sign. But we take a k goes to minus 2 limit. This is also 2 minus 2 plus imaginary. So this looks like change. So it's exponential, right? So we get very just a simple. We can keep only one exponential, and at the same time, this 2j plus 1 is also very important from the viewpoint of gravity. It's just 1 minus some energy of excitation. And then this way. So and we can predict that. So the CFT prediction just this S matrix looks like we can square because we have SU2 plus SU2, and so we get this result. And for example, if we set E equals 0, this is pi LDS over G to G Newton is this famous logical entropy in 3D. But also we can more carefully do some gravity analysis, and it's gravity duals. We excite one particle here. So this creates some. This looks like some black hole because we are exciting. So and we try to find 3D, but we have to be careful in 3D digital space. There are no black hole because there are singularity. But that is kind of analog, so we can use that solution. So this is the solution, and this is of course analog BTG black hole in ADS. And so there are no singularity as a horizon, but there are other places. R equals 0, we have a singularity. But anyway, so we evaluate action, then we get precisely the same results. And so this relates this Chern-Simon results to the CFT, this matrix result. So we can go because that we can think this structure up in detail. So actually, so in the calculation of this Chern-Simon function S3, so we paste these two solid polars together, and one with a prime. And actually, in gravity calculation, it's exactly doing the same thing. So if we look at this geometry, so it looks like one solid torus, another solid torus, and one with some deficit angle, and the other with and we paste to each other, and we get this this action. And so we can go further. So we can talk about this two link. So we have two Wilson loops linked together. This case is a little non-trivial. So we have this multiplication, and if they are disconnected, then just sum. It's more trivial. So, but the first one we can also understand the same way. So we test these two solid torus also in gravity side, and indeed we have one deficit angle and other deficit angle that correspond to two Wilson loops, and exactly gravity calculation reproduce these results. And so now it's also interesting to generalize this to higher speed probability. And so we keep about the SU2. So what about the SU3 and higher SUN? And so here we can use this idea of higher spin gravity. And the higher spin gravity in 3D is usually like HS lambda. And if lambda is integer, then this is a HS lambda theory or symmetry is basically a higher spin gauge theory with spin 2, spin 3 up to spin lambda. And for this and for our purpose, we take this SUN Chern-Simons gauge theory at level K. And this is related to this SUN with okay? But again, we use unusual limits of levels. So we put some I plus some small quantities. The CDS is effective central charge of the little space, which is a large but a real value. And so that means this imaginary piece is space. And this leads to so central charge of SUN in there leads to so this form, and this is a well-known formula, but this is written in terms of I times CDS in this limit. So, and this also again is what we expect from the CFT. And also conformal dimension is related with this formula. This is the lambda is weighted vector for representation of those. So and so we can calculate this CFT S matrix, and this also compared with higher spin. This higher spin is a bit complicated, but in the end, these two are agree with each other. And also at the same time, we can also discuss this disconnected contribution, disconnected Wilson, which is really it's like some of the two contributions. Okay, so what are the benefits of the actually to think about higher spin gravity?
Please excuse me. So when you talk about this kind of Wilson loops, so these are bulk calculations.
Yes.
So, but these bulks are Euclidean signature.
Euclidean signature. Yes.
So you start with the digital space and you weak rotate.
Yes.
So for example, when you take inner product of two wave function of universe, you have sphere, three-dimensional sphere, and you regard that as a weak rotated complete digital space.
Exactly.
Oh, I see.
Yes. In fact, I already mentioned time real time equation to this point.
I see.
Yes.
So far it's more. I can also think of this as a duality between three spheres and or
exactly.
Three-dimensional hemisphere versus CFT on two spheres.
Exactly.
I see.
Exactly. And so so this benefit to think about higher spins, this observation there also non-holographic relation, nice holographic relation with the barrier magma. And so this case we assume this following limit. So this is providing the Bachmann arguments WN minimal model, so SUN K, SUN1 divided by SUN K plus 1. If this is double minimal model, this is the equivalent to three-dimensional higher spin gravity. In the sense of the standard ADS-CFT, this is a negative cosmos. And they take this limit n goes to infinity and k goes to infinity, but top coupling lambda n over n plus k is fixed. And this itself is not directly, but actually, so in later, the variable Bachmann found duality relation called polarity. So there are three, but you pick up one of them. And that actually basically says that we can flip n and so we can just even exchange n and still algebraic structure is. So if we do that, actually, so our case actually only pick up with n, but let's divide this way. Okay, this is a nice also setup. Then our limit k goes to minus n limit. This then lambda goes to infinity. But we can regard lambda goes to infinity as n goes to infinity. And n is fixed. So n actually replaced with lambda. So then we get the algebra of HSN. That means classical spin and gravity. So actually, so this is quite naturally explained why also your theory looks like n equal to is Einstein gravity plus gravity.
Since this is a priority, there is one more limit which generates the same answer. Do you know what it is?
One limit.
One more limit.
Yeah, good question. So I cannot
see.
Yeah, but probably not so much.
Not
so much.
Isn't covered Bachmann duality? It's ADS.
Yeah, it is. Yeah, actually, imaginary things. Because everything is there. These are the things. Okay, so using the rest of time, I'd like to think about also this time evolution and also connection to something like related to quantum convention theory, like entanglement thing, we have to really go beyond history. So so far, indeed, we only talk about Euclidean signature. So we want to take some knowledge and time equation. And so yeah, in this case, so actually to understand emergence, one way to understand it is to use quantum information analogy, quantum entanglement. So in this case, we can calculate the entanglement in surface, and it's so this space and is called entanglement. So, but what about digital space? So if we just naively apply holographic entanglement entropy calculation in digital space, this is a sketch of dS3 as the same picture which I wrote before. So this is Euclidean path integral and the Lorentzian time evolution, and later time we future infinity, which is two-dimensional sphere. And we define entanglement by putting some cut A. So this A is a subsystem, and the other part complement subsystem B. So we place the subsystem B, and we define entanglement entropy for A. And then, so we can calculate this holographic entanglement by just think about some extreme surface. But in this case, I will already mentioned, so there are no space-like surface which connect this one. This is a very specialty of digital space because of exponential expansion. So we have to choose actually timeline. Only way to connect this point is timeline to geodesic and going back. But if we put some semi-sphere, then we can turn around. So there are no these going other. So if we adopt this description, so we get this form, this result. So timeline means actually, because usually we measure entropy by space-like surface area. So timeline means we put time here, and some logarithmic divergence as usual, and we get this real piece. This is half of digital entropy appears. So and we talk about is this really is one that this makes sense. But formally we can get same result from CFT. So CFT, this is just a well-known formula for if we have boundary sphere and we put some cup on subsystem A with angle theta, then C over 6 and sine square and epsilon. But we know central charge is imaginary in this case, and because time and space cut off in time and space, we have we use weak rotations. It's natural to put that here. Then actually we go back to this one. It's precisely the same. And but still, so formally maybe fine, but so what this doesn't.
So do you get this residual piece also?
Yes. So but because we epsilon goes to I.
Oh, so it comes from I.
Yes. So in any side we have a space direction cutoff, and it is related to I times time cutoff in.
Oh, I see. It comes from weak rotation.
Yes. And then, yes, but hopefully this somehow we can calculate, but what does this mean exactly? What does this mean? Make sense? So for that, actually, we want to say entanglement to be complex, but of course, entanglement should be positive, non-negative quantity as usual. So, but actually, we want to claim that this is one properly considered as more generalized quantity, which initially we call Pseudo Entropy. So the reason is actually here. So the main reason is reduced tension matrix rho A is not Hermitian in this case. So we can easily see this because we can do some Euclidean path integral on the sphere, and we can calculate it from digital side. And then digital space we have a real time, so it's over exponential IS. Function looks like IS, and this is I because of I. So if we derive this in terms of Euclid theory, so this is let's assume some curved space like this conformal gauge form. So then it's 2D function is given by Euclid theory, but we have here. So because central charge is in. So if we adopt it, then we can do path integral from this side and this side. Obviously, define state. It's not function. So these two states are defined and paste together, and we define a reduced tension matrix, and which is obviously not function. So the usual combination of entanglement we always assume density matrix is function. And so actually, Pseudo Entropy which we introduced 2 years ago is actually assume that kind of situation. But this is we consider this in completely different reason. So this actually we wanted to consider this quantity in just a standard context of area safety, because if we area safety and if we have a Euclidean time dependent, so this is not real time dependence. Euclidean time dependence, then we can define some first pass integral gives the initial state, and the other pass integral define the final state, and they are different in general. If everything is Lorentzian, is fine, because we are talking about we can create some state and Lorentzian group, and we can also start with the same state and Lorentzian backwards, and they just face each other. But in Euclidean cases, they mismatch. And in this case, we have to think instead of density matrix but transition matrix, as related psi and phi is a different state, initial state and final state. And but once we define this transition matrix, we just calculate the von Neumann quantity like power of time. And this exactly is given by this minimal surface area in time dependent Euclidean anti-Rochester space. And here we will be mine because Gojita space. And but the same thing too, because these two states are different. This is path integral and the other path integral is different. So and I want to also say that there are some closely related quantity appears also in a CFT, and especially this also we should understand this as a Pseudo Entropy. This is our latest preprint which appeared this week. And so for that, actually, so normally we define entanglement on this, of course, this timeline, space-like surface, and decompose A and the other part. And this we have this very famous formula. And if we compactify, we get this close sign. Epsilon is a unicorn. But then what about if we really rotate 90 degrees? So formally we can do this by just continuing this. Basically, this is calculation to twist operator. So we can just rotate twist operator and Lorentzian signature. And if you just honestly do that, then we get this result. This is 3 over C, because basically we can replace L goes to IT. So I generates extra piece. This structure is similar to this Gojita case. And I will finally some function. And so this is what we call this timeline entanglement, because that's subsistence timeline.
Is there interpretation of this in terms like for Neumann entropy?
Yeah, actually, this is not for Neumann entropy, but it's like more related to this Pseudo Entropy, because this initial state and final state is different. And indeed, that is.
Can you remind me? Maybe you already gave. What's the definition of pseudo entropy?
And so we define, so we aim to pick up 2 states, psi and phi, and we define this Graham, okay? And this is
oh, I see. So this is like a generalization of von Neumann entropy for non-Hermitian operators.
This tau is the same as usual. Oh.
So in the case of Dojita setup, what are the initial states and final states you are considering? Is this like a Hartle-Hawking state and the asymptotic infinity?
We are talking about CFT dual. So CFT is sphere.
Oh.
So path integral of south hemisphere gives 1 state, and path integral of north hemisphere sphere gives another state.
I see. And those 2 states are not the same?
Not the same, because it's an imaginary piece concept. The central charge is imaginary.
Ah.
Yeah, everything is real value, then of course it's the same.
Yeah, that's what I thought. So they are like complex conjugates of each other.
Yeah. It's comprehensible.
Ah, I see.
They are different.
Thank you.
And then, yeah, so for this case, we can also regard this timeline entanglement by just somehow artificially saying time direction as a space coordinate and then quantize the unusual way. Then actually, it turns out Hamiltonian is in I times Hamiltonian, or this is a usual CFT Hamiltonian. So in that sense, actually, reduced density matrix looks like if we write everything in terms of standard language, so it's like I expression I beta h, and for example, this is obviously not Hermitian. And in terms of some field double like state, this is the one state, and this state and this the other state we put the complex conjugate in this. So they usually there are no this I, so they are same because that it has this much state. And yeah, so we can, but that means that we can just compute this quantity of finite temperature and just replace it with ideal time. Then basically we can produce what we call temperature. It's related to finite temperature. And so maybe so one may wonder what's the gravity dual of this guy. So of course this guy is just a simple semi-circle. So what about this? And so actually we can easily find the answer. So this green piece is just standard piece of the extra imaginary piece is this timeless because it's imaginary. So actually it turns out that if we calculate, so this green line is like usually entanglement is related to the semicircle length, but it's go opposite because we are rotating, it's going outside actually. So this green part precisely gives this logarithmic divergence. And so in this boundary part is maybe not so easy to see, but if we embed it in a global coordinate, because it's going apart, far apart, so we have to connect again. And then we get this red line. It's really connect this. And that's also true for BTZ black hole. So we have this cinch contribution from this green part, but we have to actually connect this in time piece, and that's actually explain this. So we are part of this entropy, Pseudo entropy. This is actually basically very similar to entanglement entropy. This is related to space like geodesic. Imaginary part is something new, and this seems to be related to time like geodesic. And finally, this is fine. I already talked about Pseudo entropy or entropy in dS3 when we encounter this imaginary and real parts. We can just also do some sort of reprogrammation and then go back to time-like entanglement in ADs, and then have very similar structure in because they are related. And it seems they looks like very similar setup. Okay. And then these are conclusions. So proposal is that this first one is k goes to minus n limit of S3 and S3 with some we can add some other CFT, but there seem to be dual to classical spin and E, obviously the arbitrary status, and we can confirm the function and entanglement entropy are correctly produced. And our second author, we talked about using Pseudo entropy in the context of dS3 and dS3, and anyway, so we also imaginary piece is really seem to imply slowly imply something imagine. So maybe if we understand this imaginary part, meaning when they part from more quantum information theoretical meaning, so then might be able to understand imaginary. So basically this is a whole talk. And finally, I'd like to graduate, for example, 60th birthday. Congratulations, and really very thanks to for example, leading this field and also supporting young generation. Thank you very much.
Thank you very much for a wonderful talk. Now it's time for questions.
Have you considered calculating correlation functions in
Yes,
conformal
yes,
cases?
yeah. 2-point function actually, yeah, actually that's so we have probably so very similar. So for geometric calculation, we can calculate 2-point function, and so we have geodesic description, but there are one important piece is there are some imaginary contribution because of which come from this length, and this precisely produced from this kind of Janssen calculation because it's an involved sphere, and we cut into half. Then basically this precisely this coefficient agree with that. This is a new feature, but it's basically very fun. It's in yes.
I see.
So the fact that there has been no proposal for a unitary CFT de-Sitter duality, in some sense you don't expect one because time has to emerge, might be parallel to the de-Sitter conjecture that de-Sitter is not stable. So that means that what one should not be looking for a unitary evolution in the sense that it's decaying away. So that having imaginary parts in the Hamiltonian might be a signature of decay. Has anybody tried to make sense out of that?
Yeah, that's a very interesting suggestion. Yeah, so as far as I know, there are no good progress because it's not so easy to calculate non-perturbative quantity. But maybe lower dimensional case, maybe 2D digital space, there are also analysis of the JT gravity. And
Maybe
maybe
it's different usually 2D case is exceptionally similar. So 2D case, you might have no problem.
yes, you expect the highest
This higher one is precisely the problem.
I see, yeah. Yeah. I see, yes.
For example, does the imaginary part of the Hamiltonian has anything to do with the Hubble, the Sitter scale?
Yeah. It's related because it's the DS over G.
The Sitter conjecture roughly says that the lifetime of the Sitter is the Hubble scale. So that means that the imaginary part of that should be related to the. Is that the kind of thing you're seeing?
I see.
Well, I believe that in 4 dimension, this becomes also real, not imaginary, but negative.
You're talking about Tadashi, you must be talking about D equal 5.
Yeah, that's true. But well, D equal, but this is D equals 3, right? No?
Well, but it's true. No, yeah. Oh, this is D equals 3.
3.
Oh, so it's yeah.
So I'm talking about D equal 4.
No, yeah.
So
if you
I'm just
consider
saying
D
that.
equal- yeah, I think it would be even better if you consider D equals 6 probably, because then becomes positive real.
Yeah. That's, I think so. Yeah, but well, the realistic universe, I thought that it corresponds to D equal 4. Well, I don't know, but
Yeah, but I think it may be interesting to consider other dimensions too, because in some dimensions actually, she can become a positive real number. It may make more sense.
DS4, yes. Negative.
Yeah.
D equals 6, maybe it becomes positive real.
I don't know.
Even dimension, both dimension behaves differently.
Mhm.
So, yeah, I don't know the precise physical intuition for that.
So the CFT2, did you say?
CFT. Okay, that's also very, difficult question because we are only testing the reading or classical limit. So you are doing one loop correction basically. And also we can guess from, for example, this higher speed holography. So if we know result for higher speed holography in ADS, so we can continue spectrum to DS. But yeah, it's a bit we have some extra scalar field and so on. So that's I think one candidate. So that's, I don't know more than that. Yeah.
Well, but bulk is a weakly coupled Einstein gravity, right?
Yes.
So I should be able to figure out the spectrum, no? I mean, you can diagonalize. I mean, Laplacian in digital space, and you can read off the spectrum.
I see. Yeah, for graviton, yes, graviton.
Yes.
I think for what kind of primary field are there? So.
But you are only assuming some perturbative sector in the bulk yet. You said you are not worried about topologically non-trivial configuration.
Yeah, but still, that's primary field spectrum depends on the really choice of CFT. So it's SU2 or SU2 over U1 or maybe SL2R over U1 or SL2 or this covered when go back like double minimal model, but the details are really sensitive to that.
I see.
So I'm in confusion. In the higher spin case, there are other fields like the scalar you mentioned. Here, I thought you were making a proposal, for pure Einstein gravity. So what is the
yeah. So this one. This one actually, so yeah, this dual higher spin gravity includes scalar with some mass. If we calculate partial function itself, because there are no expectation value of scalar, so basically same thing works. So we are just focusing on gravity sector, and so not only quantity which is invisible for this primary field sector. So yeah, I think that next would definitely.
So the field is there, and you just haven't computed it.
Yeah, no, sorry, yeah, still actually in the probability of actions. Yeah, talking marking group collections. This looks very complicated so far.
Yes, question about the pseudo entropy. So it sounds like a curious quantity. So it's a complex quantity. So I don't expect any, subadditivity and things like that.
Yeah.
But I saw that graphical, your graphic derivation, because it's pictorial, it seems to go through.
Yeah, but this is okay. Good. Yes. So maybe if you, yeah, this. So yeah, it's like this, but it looks like that. But in general, this quantity is a complex variable, and so metric also complex.
Right, but
And
still,
so
your holographic argument seems to go through, like the minimum, etc.
but we cannot say minimum quality.
Yeah, well, it's
How do you write inequality for complex numbers?
well. Let's see. No, sorry. Yes. Let's see.
Yeah,
So yeah, that's right. So that area is complex.
but yeah,
It's a Lorentzian.
Yeah.
also we can this is Euclidean, so we can also
But what is minimum?
minimum. This is sorry, this is a symptomatic Euclidean, so complete Euclidean space.
Sorry, minimum of the area.
Minimum
Is the
area,
complex
so minimal area. But people think that we are assuming real valued metric, just standard radius safety.
Sorry, area is real, and then the inequality argument of rise. Sorry, I'm
Okay, so actually not true because we can. So in usual case, we can take time slice and talk about this kind of. But we cannot take time slice because time slice can be orbital in Euclidean space. So there are no right form. So it's like wavy, very wavy. So then there are no such inequality can be proved. So it's from subadditivity and so on. Subadditivity, yeah, sorry, subadditivity is okay. Some subadditivity is true. Even if we restrict with specialities.
Yes, you mentioned about the black hole, but with some holes. So does it have some
Hole is
you mentioned about diffused black holes, but you said they are not regular.
because there are singularity.
Does it have normal Hawking radiations, and can you relate the entropy to that?
You have naked singularity, right?
Yeah, naked singularity. But for from horizon, yeah, there are thermodynamics. But the black hole thermodynamics is very, logical space is very unusual. So it's, if we increase temperature, entropy decreasing, that's very confusing issues. But I think we can discuss radiation also. Yes, because it's basically dual. If we scalar field in logical space, it's same as final temperature CFT.
More questions? Is there any questions on Zoom? Let's see.
Move up. I don't see.
I don't see.
Okay.
You have to scroll up to see all the chat.
I'm looking at the chart. I don't see anything. Please, or if you have anything, please here.
Yeah. Please raise your objective speak.
Or not.
Okay, actually, I have one question. So maybe I misunderstood that your bulk description is pure gravity, or is it pure gravity plus something else?
Yeah, it's possible to have plus something, but I'm not really. I'm just interested in quantitative geodesic with the other fields.
I see.
In principle, there is a.
Yeah. So the reason why I asked this is that in ADS, it's kind of well known that there's no
No. What's the idea? Gravity, CFT dual of pure gravity.
So
Yeah, that's also clear, but maybe some minimum one is from universal. So universal with same central charge, maybe that's one candidate of pure gravity, dual of pure gravity. Of course, it's kind of defined under coordination, so it's so much here.